Hello everyone. I'm Bahita from CSE Department of Rohini College of Engineering and Technology. I'm here to explain a few topics from the subject CS 3352 Foundations of Data Science. Here we are going to discuss about describing data with graphs. So data can be described clearly and concisely with the aid of a well-constructed frequency distribution, and data can often be described even more vividly by converting the frequency distribution into a graph. The graphs for quantitative data. So we have some certain graphs to depict the quantitative data. That is, first we are going to see about histogram, a bar type graph for quantitative data. The common boundaries between the adjacent bars emphasize the continuity of the data as with the continuous variables. A histogram is a display of statistical information that uses the rectangles to show the frequency of data items in successive numerical intervals of equal size. So we have some important features of histograms, that is, equal units along with the horizontal axis, that is the x-axis or abscissa, reflect the various class intervals of the frequency distribution. The equal units along the vertical axis, the y-axis or the ordinate, reflect the increasing in frequency. The intersection of these two axes defines the origin at which both numerical scales equal to 0. Now let us see about frequency polygon. An important variation on a histogram is the frequency polygon or the line graph. Frequency polygons may be constructed directly from the frequency distributions. Now let us see about the step-up-step transformation of the histogram into a frequency polygon. The figure shows the histogram transformation. So place the dots at the midpoints of each bar top, or in the absence of the bar tops, at the midpoints for the classes on the horizontal axis, and connect them with the straight lines. Anchor the frequency polygon to the horizontal axis. First extend the upper tail to the midpoint of the first unoccupied class on the upper flank of the histogram. Then extend the lower tail to the midpoint of the first unoccupied class on the lower flank of the histogram. Now all of the area under the frequency polygon is enclosed completely. Finally, erase all the histograms bars, leaving only the frequency polygon. Will get the diagram as shown. Now let us see about the stem and leaf displays. The stem and leaf displays are ideal for summarizing the distributions, such as that of for the weight data, without describing the identities of individual observations. So this is a diagram which shows the stem and leaf data. Now let us see about the typical shapes. Whether expressed as a histogram, a frequency polygon, or a stem and a leaf display, an important characteristic of the frequency distribution is its shape. The figure below which shows some of the more typical shapes for smooth frequency polygons. So this is the diagram which shows normal, bimodal, positively skewed, negatively skewed diagrams. Now let us see about a graph for qualitative, that is nominal data. As with the histograms, equal segments along the horizontal axis are allocated to the different words or classes that appear in the frequency distribution for qualitative data. Likewise, equal segments along with the vertical axis reflect the increase in frequency. The body of the bar graph consists of a series of bars whose heights reflects the frequencies for the various words or classes. The gaps are placed between the adjacent bars of the bar graph to emphasize the discontinuous nature of the qualitative data. So this is the misleading graph. So misleading graph, the graphs can be constructed in an unscrupulous manner to support a particular point of view. The popular saying that numbers don't lie in statistics do. So there are three kinds of lies, damn lies, and statistics. Thank you.